Good morning. I'm Michael Kovnat, and this is the Next Big Idea Daily, where we bring you key insights from some of today's smartest nonfiction writers. Now, unless you have a degree in computer science, you might feel, like I do, that software coding is a mysterious modern magic. From the basics of BASIC to the elaborate instructions powering AI, code runs our cars, curates our music. Sometimes it even seems to read our thoughts. Such a powerful tool shouldn't just be the domain of a tech elite. In fact, Samuel Arbesman believes coding should be taught as a liberal art. He's a scientist, a writer, and a thinker who believes that programming is one of the most human things we do. In his new book, The Magic of Code, he explores how computing connects with philosophy, art, and mythology. Here he is to share 5 big ideas about how digital language shapes our world and what it can teach us about ourselves.
I'm Samuel Arbesman, scientist in residence at Lux Capital and the author of several books, The Half-Life of Facts, Overcomplicated, and most recently, The Magic of Code, How Digital Language Created and Connects Our World and Shapes Our Future. As you will hear, this book is about many different topics, but it is really the kind of book I wish I had when I first encountered the world of computers, one that was beyond programming or beyond specific use cases. It's about how computing is connected to so many different aspects of our lives and the world around us, and how by recognizing this, computation can help us think about the world and our own humanity. Also, it's a kind of love letter to the computer. I'd like to share 5 of the key ideas from this book. Computing should be a liberal art. When people think about computing, or just the nature of code, it's often in the context of a branch of engineering. And there certainly is a lot of that. But when I think about computation, it's something much broader. Computing in my mind is not just software. Understanding it combines mathematics and logic with language and philosophy. It weaves in biology and simulation, how we think, and how we make art. As I argue in The Magic of Code, code and computation is a kind of universal solvent, drawing in basically every aspect of our experience, from the ancient myths we tell to how we think about physics. Thinking about computation as a liberal art is certainly fun, but it's also vital, because if you keep everything siloed, you're going to be hamstrung in trying to figure out how we might engage with technology. We need to view computing as this all-encompassing humanistic discipline in order to properly understand it. And in doing so, it might even help repair our relationship with technology, no longer viewing it as something to be skeptical of, or worried about, or even as an adversary. It can certainly be these things, but it can also be so much more. It can be a source of wonder and delight and connection. For me, when I think about working with computers, I think about my family's experience with the Commodore VIC-20, or the first time I ever used a mouse on a Mac, or experienced the internet, or played with screensavers, or saw a computer model of simulated flocking birds. These were all unbelievably exciting experiences, and they were due to the strange and interdisciplinary abilities of the computer. There are many reasons for concern. Certainly issues around social media and AI are concerning, but there is also so much potential as well. If we are deliberate about how we think about technology, and if we understand it well, and as this liberal art, we as a society can make sure that what we build makes us the best versions of ourselves, rather than the worst. Computer code is real-world magic. As a society, we yearn for the ability to use words and text to coerce the world around us. We have yearned for this sorcery, from ancient traditions of magic to our fantasy stories. Less than a century ago, this desire became a reality with the digital computer. We created the ability to write code that could act in the world. Code is magic made real. Of course, taking this analogy too far is not the best idea, but it turns out that when you look at equating magic with coding, you find intriguing insights into how to think about computation. For example, in our stories of magic, magic doesn't necessarily just work. Magic takes craft and effort. You have to go to Hogwarts for years, after all. So too with programming. There is an art and a science here. The crackling power is deeply connected with a precision. And so too are there other parallels. For example, names for magical control is a common idea in our stories of sorcery. Know a name and you can control something or some force. It turns out that there are some interesting parallels with variables in computer code, where understanding a variable's nature and scope is a sort of power. There are even global variables, which programmers are counseled to avoid since they are far too powerful. So too is the matter of sacrifice. Something of value must be given for magic to work. An intriguing example of this in computing is the fact that we have to train our massive AI systems by giving them humanity's creative works. This seems kind of like sacrifice. And there are more such examples. Ultimately, thinking about magic is more than a fun analogy. It can teach us something about computation. With great power comes great responsibility. Let us not ignore the power inherent in the real-world magic we have available. Code. Programming languages are for people. How computer programming works is a moving target. What might have once been the province of switches or cables, or even writing ones and zeros, has become strings of text. Programming languages have come and gone, and we are now generating software in collaboration with our AI servants. These are all part of a tradition of trying to take half-formed ideas in our minds of what we want machines to do and turning it into this strange material of code, text that can act. But in the end, whatever language we use, we must remember something noted in the seminal computer science text, Structure and Interpretation of Computer Programs. Quote, "Programs must be written for people to read, and only incidentally for machines to execute." Unquote. Programming and programming languages are for people. Just as humans communicate with all different languages, programmers are surrounded by a profusion of languages too, from Python and Perl to JavaScript and C. It almost feels like new programming languages crop up like weeds, with new things to learn all the time. Whether entirely new human languages, or just new jargon or slang that each of us feel compelled to understand, this need to learn new language, both natural and computational, feels very human. There is also a deeply human aspect to code itself, which is why different programming languages and different programmers might have a unique style. There is even a book entitled If Hemingway Wrote JavaScript, and the language Perl took this all very seriously. It was actually developed with ideas from natural human languages in mind, and that means that there needs to be a lot of ways of expressing yourself. As its creator Larry Wall noted, quote, "I'm a firm believer that a language, whether it's a natural language or a computer language, ought to be an amoral artistic medium." Unquote. Engaging with machines is a strange thing, something that blends how we think and communicate with the need for logic and precision, and it also bridges the machine and the human. So as much as we think of it as a process devoid of humanity, it is very much the opposite. Programming languages are for people. Building software is like sharing ancient mythological stories. There aren't really canonical versions of ancient mythological tales. Over time, these stories changed and were altered in the retelling. Bits added and removed, and the ones that resonated with audiences stood the test of time. As a result, we have a huge number of versions of Hercules and Zeus, Odysseus and Apollo, and the ones that spread are often the most exciting and compelling versions. This is also related to the idea of how we think about innovation, where new ideas or products or stories are generally created from pre-existing components. And it turns out, all of this is not so different from how software is built, and in particular, open source software. Like an ancient tradition, open source software might be part of a community, modifying and changing what has come before it. There is a balance between maintaining what has come before with innovation and creating something new. But all of this needs to be part of a community, whether we are thinking about stories or code. And open source software, by being able to be built upon, continues to allow for open-ended innovation in software more generally. No one needs to start from scratch, whether we are talking about myths or apps. Ultimately, in many ways, the evolution and maintenance of ancient Greek myth is no different than Unix, and just as exciting. Debugging can teach us humility. Writing software is rarely an act of pure creation. More often, it is an act of frustration, or at least correction. It's so frustrating because making software that works is really hard. Code is rife with bugs, glitches, and unexpected behavior. The act of shortening the distance between how you want something to work and how it actually does its thing, this very act of debugging, can be quite exasperating. But it is a way of life, at least for the programmer. And through the act of debugging, we can learn something about humility. It can allow us all to recognize that there are limits to our understanding big and complex systems. Human minds are quite limited, and debugging makes that abundantly obvious. Whether it's realizing that we were counting something off by one, or forgetting how our systems are not entirely text and ethereal, but sometimes deeply physical, wires and cables and microchips that can fail, and so much more, debugging is almost a monastic activity devoted to teaching the limits of humanity. This process of debugging can also be incredibly eye-opening and teach us the world is weirder than we might have realized. There is story after story told about glitches that can teach us this, from Wi-Fi being affected by the rain, to a helium leak in an MRI machine that was affecting iPhones. There is even a story told about emails only being able to be sent about 500 miles, which, when analyzed, involved both software and the speed of light. Bugs in computers certainly can be bad, but they are often a certainty. So at least let them teach us something, the fact that we are not angelic beings, but imperfect creatures. We are human.
Thank you, Samuel. All right, everyone, you can get a copy of The Magic of Code using the link in the episode notes. That's our show for the day. If you got something out of it, please leave us a rating or review in your podcast player. We really appreciate it. And head over to the App Store to download the Next Big Idea app. It'll give you access to thousands of big ideas right in your pocket. I'm Michael Kovnat. Hope to see you tomorrow.